4G. And this is why we can't have nice things. Hi Magic Folk, today we are talking about 5G and 4G and what 5G means, how it works, and what it means for AR, more specifically in the Wizards Unite environment, but also in a wider environment. So why are we talking 5G? Well, Niantic actually had a 5G demo at a recent conference. They had the Samsung Galaxy S10 and they actually had 5G receivers in the room where they were demoing it, and they were also demoing Codename Neon. Codename Neon is the first-person shooter where you can see through your phone and you can see your enemies and you can pick up these like ball things and you're supposed to throw it at them to score against them. And this is quite a cool mechanic, and you can kind of see where zapping people with things could be very useful in Wizards Unite. Another demo is something called Tonehenge, and this is a puzzle solver where three people in the demo solve a puzzle together. Looking through their phones, they can see a character overlaid over their friends, and then they solve a puzzle together as these characters in an AR environment, which is pretty cool. And again, you can see how this could be incorporated into Wizards Unite, as in you can have some sort of mini-game puzzle solver thing that you have to work together as a team, maybe in a fortress, to solve and get mini books and moonstones and really cool things. So why can't 4G do it? Well, it's nothing to do with the amount of data transfer per second. So it's actually nothing to do with internet speed. Although, if you try using 4G in somewhere like London, you'll know it's near or impossible and pretty much useless. This goes the same with 3G before that, because the faster services we get, the more devices we get, and it slows down the services again. So now 5G. And why is 5G going to be different? And if it's not speed, then what's the problem? Well, the problem is what we call latency. And latency is the time it takes for my phone, for me to press a button, my phone to send that signal through the towers, through the internet, over to Niantic servers, them to process that command, and then send the information all the way back to me. And that's called latency. And you measure that in milliseconds. And I've been doing a few tests. So the magic number, according to Niantic, is 10 milliseconds. So that's the time it takes for the command to go from my phone to Niantic servers and then back again with a reply. And so my game knows what it's doing. Now the only way I can achieve anything under 10 milliseconds is by using a speed test, because that does what's called a ping. And if I do that on my home Wi-Fi, it will communicate with a server based locally, and that server is about 20 miles away. Now, with a server 20 miles away and me using Wi-Fi, I can get a 9 millisecond ping, which is just within the 10 millisecond threshold. But now, if I switch my phone over to 4G, I get a somewhat different result. From my house, I can't actually get 4G. I actually get 3G or H+. And that gives me a ping to the same server of 60 milliseconds. So all of a sudden, we're 6 times over. Now, when I've tested this at work, where I do have a 4G connection, you're looking at 50 milliseconds. So we're still 5 times over what is actually recommended. So that's testing just the networks, okay? So we've got a server which is relatively local, and we're purely testing Wi-Fi versus cellular network. But we can also test is location of our servers. So those servers were about 20-30 miles away. I can now select another server, which is now 200 miles away. We can run a same test using Wi-Fi, because it's kind of our stable connection, and let's see what we get for a ping. Now, we were getting 9 milliseconds before. We've now jumped up to 16. So now we've gone past the 10 millisecond threshold, not by our network, but where our server is located. So the time it takes my signal to go 200 miles away and come back again. Now, this is where the second part of Niantic's solution is. So our first part is a 4G network, which as we can see brings us down from 50 to 9 milliseconds, providing our server is local. And the second part is what's called edge technology, and that's where they bring the servers more geographically local to where you are to reduce that distance. Now we can already see actually how much that has affected our tests here. Now Niantic have been working with South Korea Telecom and Deutsche Telekom on what they call their edge technology, and that is placing servers geographically local. This makes a lot of sense because if I am here in my local area with my 10 friends, we don't need to be sending all our data over to a massive data center and back again, when there could simply be a server local just dealing with our requests. And that server will be loaded with all the map data and necessary Niantic programming of their AR platform thing to actually deal with our requests and keep all the traffic local and within a low latency, hopefully within that 10 millisecond threshold. So what happens if we go above 10 milliseconds? So as you can see in the codename Neon demos, the phone is tracking where each person is. So when you throw the ball thing to hit them, it's tracking them in real time. So the phone has to be aware of where they are and whether they're scoring a hit or whether the thing you're throwing is going the right direction. But that's not all computed by your device, that is actually computed on the cloud. So in order for Niantic's servers to understand who is who and where everyone is, it has to have the information quickly because everyone's moving around. I mean, it's fine if we're all standing still and it's not so bad, but if you look at the Tonehenge demo, we have characters overlaid over the top of our real characters. Now the longer that delay is, that overlay is going to be behind our person we're trying to track. And then you can get all sorts of problems with missed hits and things not timing correctly, all because you have the dreaded latency, or in other words, lag. And everyone knows who's a gamer, the whole dreaded lag thing, where you actually shot someone and then it turns out you haven't shot someone. And you can see that in Pokemon Go, where you were dodging, trying to dodge a hit, and it may, or you think you have got it and then you got hit, or you did dodge it, you get hit, and then the energy comes back, and that's all to do with latency and the server's not quite understanding what is happening when that thing between your thumb movement and the target shooting at you or whatever. So how does 5G work and how does it differ from 4G? So in this graphic we can see our communications. So we've got our local area, we have our mobile phone, we're sending a signal up to our 4G tower. It then goes through all the local network hubs and servers and stuff, and then out through the internet. It then muddles its way through the mesh of internetness over to Niantic's real-world platform, where it's then processed, sent back through the internet, through the local network, through that tower, and then to your phone. So what happens with 5G? Well, the amount of connections a single cell tower can handle is dramatically increased. So we won't be flooding our receivers, as if we're all standing in a big area like Chicago's Park, for example, trying to play Pokemon Go. We're not going to saturate those local towers. On top of that, your phone has a greater frequency range. That means that the amount of bandwidth a single phone can have to that tower is greatly increased. More about that in a second because it has caveats. The connection between the 5G tower and the rest of its network in the back end is also greatly increased. This is down to sort of new technologies and fiber optics as we sort of progress through the years. And then we're back to the internet, back to Niantic again. To solve the high latency between the internet and Niantic's like top end servers, that's why we're placing these edge servers in your local area. So there's less distance for it to go, and the bandwidth is also greater. So it all looks rosy. Except that there are design problems with 5G, which has taken a great deal of effort for them to try and overcome. Now, because we're using frequencies which are really high, which are called the millimeter bands, these are easily blocked by walls, people, and even your hand. So your phone will need a direct line of sight to a cell tower. So these high frequencies behave much in the same way as if you're listening to music, for example. So say you have a decent stereo playing in one room, and you go turn the volume up, and you go outside, and you listen through the walls, hopefully not annoying your neighbours. But what can you hear from outside? You can usually hear the bass thumping and some mumbling, but you can't hear the high-end frequencies. You can't hear singing very well. It's mostly like thump, thump, thump. You know when you hear a car going down the road, the stereo turned up, all you can hear is the bass sound. You can't hear the high frequency sounds. That's because the high frequency sounds get trapped within the car, and the bass sounds are able to penetrate the car's shell, so you can actually hear them. And this is kind of the same for radio frequencies, but obviously a lot higher frequencies that you can actually hear, but it's kind of the same principle. 5G phones actually have antennas placed in different parts of the phone, so your hand can't possibly block the aerials. So you also have to have cell towers in front and behind you in case your head is blocking the signal, or other people, or you just go around the corner of a building. So the problem here is a city with lots of buildings and walls and people and stuff in the way, general stuff in the way. It's going to need a hell of a lot of these cell towers with very fast connections in the background. So the sheer amount of hardware required for 5G in the city is quite astounding. And CNET did a test with the Moto 5, I think what it is, with this special 5G connector on the back of it, and it was terrible. It didn't really work properly. It may have been this 5G dongle thing they had to put on the back, but it certainly wasn't a good start. So the chances of getting 5G anytime soon is not likely. And on top of having 5G in your area, as we demonstrated before, you're going to need an edge server which deals with the specific game you're playing. So Niantic will have to have servers in multiple locations in order for you to play wizards like Pokemon Go, etc. with super low latency. So I don't see this coming anytime soon. I mean, we're going to be looking, I reckon, at least 2-3 years just to get the hardware in place to actually be able to support all this low latency gaming stuff. Also, if you're working inside a building, you'll also have to have 5G inside the building in order for it to work properly, or default back to Wi-Fi. And as we did look, a decent Wi-Fi connection can achieve under 10 milliseconds. So you don't necessarily need 5G inside a building to get low latency, providing there's an edge server nearby. For those of us in suburban areas, we actually have a slight advantage because we don't have so many high-rise buildings and objects and that in the way in suburbia. So the 5G rollout could actually be slightly smoother in suburban areas than in city centres. But then, of course, you have larger suburban areas than you do have city centres. So again, it's going to take a long time to roll this out. I mean, if you thought 4G took a while to get out, you can imagine how long 5G is going to take with all this extra equipment they need. So don't expect it anytime soon. Will I be rushing out to buy a phone? No, not yet. Because being early adapter of 5G, much like I guess it was how 4G was, it took a while for the technology to catch up. There were a number of frequencies that weren't supported by early 4G models, which meant you had to kind of upgrade to be able to use all the 4G towers properly, as they make tweaks to 4G and 5G as they go, as they deploy more. It will change things. Also, I think there are a number of new chips coming out for 5G as well, which aren't out yet, which are smaller chips and more efficient as well. So don't rush out and buy a 5G phone right now. Wait until there's coverage in your area, as in where you live, where you play Pokemon Go, if you play Pokemon Go, where you work, where you go to school. Check on the coverage maps as 5G is rolled out, and when you start getting coverage in the areas that you're going to be day to day, then it's probably about the right sort of time to start looking at a phone if your contract is up, or if you're rich and buy phones outright. So I hope that is helpful. Follow me on Twitter @TheZillman for the latest news and strange things that I say. I'm not afraid to speak my mind on Twitter, not to the point where I get sued, but to the point where I kind of reflect the community as a whole, I think, in some games. Sit tight, everybody. Get your wands ready. Brush up your spells. Wizards unite.